Okay, we're back. In this video, we're continuing the analysis of the initialization routine. Whoops, where'd it go? Standard main loop init. So we covered all of this so far. Um, Console initialization, file system initialization, uh, all of this stuff. Where we're stopping, or where we stopped last time, and where we're continuing off is here. At init. Once again, this is Win32, the platform being analyzed on, in case you didn't watch any of the earlier videos. And this is just for my own personal use. If you're using this, keep that in mind. So here we go, processor init. Let's go ahead and step into this. Excuse me, I'm kind of under the weather. So processor init. Mm, so it's a significant amount of assembly here, which is actually gonna run, I believe. Mm, mm, hmm. So it's basically setting vendor, or it's is it utilizing vendor? No, because it's defined here. It's setting vendor. Yeah, you can see EBX, EDX, ECX. Maybe 3D later. I wonder what that is. I have no idea what that is. Huh. Oh, here it's a label. So maybe 3D later exit. Yeah, so it's just flowing down. Excuse me. So I'm gonna start a breakpoint here. Going to step over, 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 step over. Type unknown x86 compatible properties. Okay, so here we're executing the individual assembly. You can see the actual values. So it doesn't do that jump there. So it checks for 3D now. Okay, cool. That makes sense. Mm, Processor properties, properties 2. Is properties 2 set up here? Oh yeah, properties 2 is ECX. Okay. Okay, so yeah, that makes sense. So the assembly, all it does is it gets some CPU feature information from flags and uses it to set processor info. So I bet if we step into here, all it'll be doing is assignments. So properties is a flag, or equals. So it says FPU RDTSC or MMX. So it should set all of these. So properties should 4097. It should alter on every single step of execution. So I'm gonna break, break. Let's go continue. 4099. You see that? Okay, so this should execute and this should execute. So go boom. 4131. Oops. Actually, I don't need that. I can just step over. 4135. So you can see each one of these CPU features is enabled. Mm, so P info. P info properties. Where does P info come from? Hold on. Oh, okay, this is internally. So this comes direct and this comes from this. Step. So it should be like something else. Yeah, there we go. So it's masked up. So, okay, CPU, Intel unknown, processor, shifted 8 bits, and 0xF. Sorry, the video stopped. Listening to It's Always Sunny in Philadelphia on the background. Super good. Um, hmm. So this is an old 46. I guess it goes all the way back there. I guess, I doubt it's supported on a 46 at all. But this processor object might be. I mean, the engine as a whole versus this particular method. I think they just have support for 486 just for recognition purposes. Mm, I'm going to set a breakpoint here in case this is where the breakpoint. Hold on. What's going on here? I don't want that. I want. Is this a cascading else? Okay, I get it. I should put a breakpoint here. Okay, we bypassed all of this. You can see we're here. P info now is full of the relevant instruction information. Here we have mm, name. Is the type just a character or something? Character pointer, right? Yeah. So type is CPU Intel Pentium 3. Oh, excuse me. So I'm assuming when we bypass this, or we actually execute over this, that information is going to be filled out. Like I said, this isn't a security audit, so I'm not going to go into each of these individually. I do think that maybe I should investigate this, but I doubt it's very necessary. Um, yeah, the security audit stuff I was talking about in the last video, in case you just jumped in here. Okay, so I'm going to step over that, step over that, step over that. I don't even need that. Okay, here we go. So the megahertz rating isn't filled out yet. Um, so here you can see we have 8 cores, one physical processor, and 4 available. And these are the features as we went over earlier. Let's see if anything else filled out. I'm wondering when that megahertz rating is filled out. If it is, you know what? I guess it doesn't. I guess it doesn't get filled out. Weird. Okay, continue. Oh no, I hit the wrong button. No. What I did was I hit the continue button when I should hit that step over button, so I missed out on some code execution. I'm not sure exactly how much. I'm going to go ahead and set a breakpoint here. I'm going to stop debugging and start it over. Because there's some things I really, really need to go over. So yeah, stopping, restarting. So torque win main, if you remember, that's where we started off in the application. Torque main is where we want to get. Engine init. Standard main loop init. This is where we just set the breakpoint. So this is the breakpoint in the application itself. Hold on. Processor init. Okay, step over, step over, step over, step over, step over. Mm. So 2.2 gigahertz is the megahertz rating of this particular chip. Kind of slow. Console output. Okay, so if I was gonna make any changes in the future as to how the output like came out to the screen, I could just remove all these console prints. I could go through the engine itself and just destroy them. That's something that I would do probably. Platform blit in it. I don't know what that is. We're gonna go into that. Bitmap extrude. So is this a function pointer? Extrude RGB platform processors. VC inline x86 ASM. Hmm. Okay, so it sets these two functions. I guess they're function pointers. Hold on, let's just make sure. Yeah, these are function pointers to the MMX versions of those function pointers. Because my processor supports MMX, that's where it's done. So I'm not sure what those bitmap images or those bitmap functions are for. I'm sure in the future, as I analyze more, I might gain a better understanding of them. Right now, though, meh, I don't know. So now the math subsystem is being initialized. We can look in there. I'm sure there's nothing really that interesting in there. Da, da, da. It's all library C. It's all library assembly. So I don't know if this actually does anything. Uh, so I guess it just assumes everybody has an FPU, so it doesn't do anything here. But here down with MMX, it says m install AMD math. So if I set a breakpoint there and I go do, oops, oh, mm, mm, mm. So it should enter here. I guess not. Oh, it's because my processor's Intel. It wouldn't actually go here. 3D now is an MMX thing. So it installs SSE. Okay, I'm gonna go ahead and look at platform edit now. Mm, we might want to change this. Well, you know what? Maybe platform Windows is okay. Maybe there's a 32, 64-bit differential variable somewhere set that I don't know about, but this is available in the console, I believe. Mm, I don't know what Redbook is yet. I noticed in the application itself it references Redbook. I don't know what that is yet. Mm, hmm. Mm, I'm not sure what's going on in here. Set a breakpoint right there just in case. Okay, so it didn't actually read that. Hmm. Okay, I'm gonna stop it. Start it again. I need to re-enter the application. Continue. 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 Step into. So we did processor, we did math. We looked at platform a little bit. No, wait, we were looking at platform. So let's go back in there. Step. Mm, so here's where it initializes input. So hold on, I gotta understand this a little bit better before I can even speak on it. Okay, so here's where it creates a new DirectX input manager, tries to enable it. If it can't enable it, it exits. I'm sorry, it doesn't exit, but it just says that it's not enabled. If not, it initializes it. Modifier keys here, fill ASCII table, print F, just a new line for whatever reason. Hmm. So here it's part of per frame processing, I guess. Whew. Okay, so here we are at init input. Step into that or step over that. Um, we know we're good on that. We know that that initialized okay. This I don't know. I don't even have any idea what Redbook is. Get logical drive storage. Hold on 1 second. Let me Google Red Book. Hopefully it doesn't come out to RedTube. Where is it? Red Book devices. IBM Red Books. Okay, you know what? I have no idea what that is, and the Google search didn't help me make any sense of it. Oh wait, maybe it's a CD-ROM thing. Hold on. Okay, so, Red Books are part of, I mean, sorry, the Red Book is part of the Rainbow series, and apparently it has to do with compact disc digital audio. So this, I guess, just enumerates each drive. Okay, so here we have logical drives. Here, I guess all it's doing is wait. New character D Sterling stir +1. Oh, okay. Yeah, all it's doing is going through each individual CD-ROM drive on my computer and trying to load it, I guess, as a Redbook device. Okay, I get it. Mm, one of my drives is an optical drive, so stir is F colon. So my F drive is a CD-ROM drive. So after we install the Redbook devices, SG double byte enabled. Get system metrics. Okay. So I get it. Redbook, CD-ROM stuff, straight up CD-ROM stuff. Platform is Windows stuff. Math is what math to use. Processor is process information, kind of nitty gritty process information. Um, so initialize console here. For the sake of thoroughness, I'm going to step into this. So remember the platform is Windows, so it'd be Windows colon colon background sleep time. Windows colon colon time manager process interval. I dig it. That's kind of cool. Create singleton. So I think this is where we create the global thread pool. Let's step into that just to make sure. Yeah, it just creates a new one. Module manager initialize system. Okay, this is something we're going to want to look at entirely. I'm not sure if that's where any code is loaded, like in terms of pork script or what, but we're making progress. So I'm gonna go through this before I conclude this part of the video, but yeah, we're on the way. Exhaustingly so. Okay, stopping this.